Hello, brilliant minds. Welcome back to our channel, where we break down complex tech topics into easy-to-understand lessons. Today, we're diving into a foundational concept in machine learning that every beginner should know. Whether you're just starting out or brushing up on the basics, understanding how machines learn is essential for anyone interested in AI or data science. We'll explore the three main ways machines learn, using simple analogies and real-world examples to make everything clear. So, get comfortable and let's embark on this journey together. Ready to unlock the secrets of machine learning? Let's get started. Imagine you're teaching someone in three different ways. First, by showing them examples with answers. Second, by letting them find patterns on their own. And third, by allowing them to learn through trial and error with rewards. These are the three main types of machine learning: supervised, unsupervised, and reinforcement learning. Understanding these is like having a map to navigate the world of artificial intelligence. Throughout this video, we'll break down each approach, explain how they work, and show you where they're used in real life. Let's begin by exploring supervised learning. Supervised learning is like having a teacher guide you. The machine learns from labeled data that already contains the right answers. Think of it as a student studying with flashcards. Questions on one side, answers on the back. The algorithm looks at input-output pairs and learns to map inputs to the correct outputs. This method is widely used in real-world applications, such as email spam detection, house price prediction, and image classification. The most common algorithms include linear regression, logistic regression, decision trees, and support vector machines. Let's see how this works in practice. Let's look at some real-world examples of supervised learning. Imagine your email app filtering out spam. It's trained on thousands of emails labeled as spam or not spam. Or consider predicting house prices, where the algorithm learns from past sales data, using features like location and size to estimate value. In image classification, the system learns to recognize objects by studying labeled images. These tasks all rely on having labeled data, where the correct answer is known. Supervised learning is the foundation for many practical AI solutions you encounter every day. Supervised learning uses a variety of algorithms, each suited to different types of problems. Linear regression is great for predicting continuous values, like house prices. Logistic regression helps with classification tasks, such as determining if an email is spam. Decision trees visually map out decisions and their possible consequences, making them easy to interpret. Support vector machines are powerful for separating data into categories. Each algorithm has its strengths, and choosing the right one depends on your data and your goals. Unsupervised learning is all about discovery. Here, the machine finds patterns in unlabeled data. There are no right answers provided. Picture yourself organizing a messy room by grouping similar items together, without anyone telling you how. The algorithm explores the data and uncovers natural groupings or structures. This approach is used for customer segmentation, anomaly detection, topic modeling, and recommendation systems. Unsupervised learning helps us make sense of complex, unstructured data by revealing hidden patterns. Let's see unsupervised learning in action. In customer segmentation, businesses group customers based on purchasing behavior to tailor marketing strategies. Anomaly detection helps spot unusual patterns, such as fraudulent transactions. Topic modeling uncovers themes in large collections of documents, while recommendation systems suggest products by finding similarities among users or items. These applications show how unsupervised learning can extract valuable insights from raw, unlabeled data. Unsupervised learning relies on algorithms designed to find structure in data. K-means clustering groups data points into clusters based on similarity. Principal component analysis, or PCA, reduces the complexity of data while preserving important patterns. Association rules help uncover relationships between variables, such as products often bought together. These algorithms are essential tools for exploring and understanding large, unlabeled datasets. Reinforcement learning is all about learning from experience. The machine interacts with an environment, making decisions and receiving rewards or penalties based on its actions. It's similar to training a dog. Good behaviors are rewarded, while bad ones are discouraged. The perfect analogy is a video game player learning to beat a level through repeated attempts. Over time, the machine learns which actions lead to the best outcomes, improving its performance through trial and error. Reinforcement learning powers some of the most exciting AI breakthroughs. Game-playing AIs like AlphaGo and chess engines learn strategies by playing countless games. In robotics, reinforcement learning teaches robots to walk or manipulate objects. Self-driving cars use it to learn safe driving policies by interacting with simulated environments. Even resource management in data centers can be optimized using reinforcement learning, as the system learns to allocate resources efficiently through feedback. To understand reinforcement learning, it's important to know a few key concepts. The agent is the learner or decision maker. The environment is the world the agent interacts with. Rewards are feedback signals that tell the agent how well it's doing. Through repeated interactions, the agent learns to maximize its rewards by choosing the best actions. This process is at the heart of many advanced AI systems. Now that we've explored each type, let's compare supervised, unsupervised, and reinforcement learning side by side. Supervised learning uses labeled data to predict outcomes, with direct feedback on right or wrong answers. Unsupervised learning works with unlabeled data, discovering hidden patterns without feedback. Reinforcement learning doesn't start with data, it learns by interacting with its environment and receiving rewards or penalties. Each approach has a unique goal and process, making them suitable for different tasks. Choosing the right learning approach depends on your data and your goal. Use supervised learning when you have labeled data and a clear prediction target. Unsupervised learning is best for exploring data and finding hidden structures. Reinforcement learning is ideal for sequential decision-making, where actions influence future outcomes. Understanding these differences helps you select the best tool for your specific problem. Let's apply these concepts to a real-world scenario. Customer analysis. With supervised learning, you can predict which customers are likely to churn, using historical data with known outcomes. Unsupervised learning helps you group customers into segments based on their purchasing behavior, revealing patterns you might not have noticed. Reinforcement learning can optimize marketing strategies by testing different approaches and learning from feedback, such as in A divided by B testing. Each method brings unique value to the table. In image processing, supervised learning is used to classify images, such as distinguishing cats from dogs using labeled photos. Unsupervised learning can group similar images together without knowing what they contain, which is useful for organizing large photo collections. Reinforcement learning enables robots to navigate environments using camera input, learning to avoid obstacles through trial and error. These examples show how each learning type can be applied to the same domain in different ways. Gaming is another area where all three learning types shine. Supervised learning can predict player behavior based on historical data, helping game designers improve user experience. Unsupervised learning uncovers common patterns among players, such as preferred strategies or playstyles. Reinforcement learning powers AI opponents that learn and improve through practice, making games more challenging and engaging. The versatility of these approaches is evident in the gaming industry. If you're new to machine learning, start with supervised learning. It's the most intuitive, has the largest number of practical applications, and forms the foundation for understanding other types. Once you're comfortable, move on to unsupervised learning to explore data in new ways. Finally, tackle reinforcement learning for more advanced, interactive applications. This progression will give you a strong grasp of the field and prepare you for a variety of roles. For aspiring data scientists, mastering all three learning types is important, but supervised learning is especially crucial. Most business problems involve labeled data and clear prediction goals. Data scientists use supervised learning for tasks like forecasting, classification, and regression. However, understanding unsupervised and reinforcement learning expands your toolkit and opens up more advanced opportunities in research and development. Research scientists often work with reinforcement learning, pushing the boundaries of what AI can achieve. They design algorithms that learn from complex environments, such as robotics or game-playing agents. This work requires a deep understanding of how machines learn through interaction and feedback, as well as creativity in designing new learning strategies. If you're interested in cutting-edge AI, reinforcement learning is a key area to explore. Business analysts primarily use supervised and unsupervised learning to extract insights from data. Supervised learning helps predict business outcomes, while unsupervised learning reveals hidden trends and customer segments. By understanding both approaches, business analysts can make data-driven decisions that drive growth and efficiency. Reinforcement learning is less common in this role but can be valuable for optimizing business processes. It's easy to make mistakes when choosing a machine learning approach. Don't use supervised learning. If you don't have labeled data, it won't work. Avoid unsupervised learning when you need specific predictions, as it's designed for exploration, not forecasting. Reinforcement learning isn't suitable for simple classification tasks. Most importantly, always understand your data before selecting a method. Careful planning leads to better results. In real-world applications, these learning types often work together. For example, you might use unsupervised learning to discover customer segments, then apply supervised learning to predict behavior within each segment. Reinforcement learning can further optimize marketing strategies for each group. Combining approaches allows you to tackle complex problems more effectively and get the most value from your data. Remember, there's no single best type of machine learning. The right approach depends on your specific problem and the data you have. Sometimes, combining methods yields the best results. Stay flexible and choose the tool that fits your needs. As you gain experience, you'll develop an intuition for selecting the right method for each challenge. The lines between learning types are blurring. Semi-supervised and self-supervised learning are becoming more common, combining elements of supervised and unsupervised approaches. These methods use small amounts of labeled data with large amounts of unlabeled data, making machine learning more accessible and powerful. Staying updated on these trends will keep you ahead in the rapidly evolving field of AI. Let's quickly recap what we've learned. Supervised learning is about learning from labeled examples, mapping inputs to outputs. Unsupervised learning finds patterns in unlabeled data, uncovering hidden structures. Reinforcement learning is all about learning through trial and error, guided by rewards and penalties. Mastering these three types gives you a strong foundation in machine learning. Understanding the three fundamental ways machines learn is crucial for anyone working with data or AI. It helps you choose the right approach for your projects, communicate effectively with teams, and stay competitive in the tech industry. Whether you're building models, analyzing data, or making business decisions, this knowledge empowers you to make smarter choices. The world of machine learning is always evolving. Stay curious, keep exploring new concepts, and never stop learning. As you build your skills, you'll discover new opportunities and be better prepared to tackle the challenges of tomorrow. Remember, every expert was once a beginner. Your journey is just beginning. To continue your journey, focus on mastering supervised learning first, then expand into unsupervised and reinforcement learning. Practice with real data sets, experiment with different algorithms, and seek out projects that challenge you. The more you apply what you learn, the deeper your understanding will become. There's a world of possibilities waiting for you in machine learning. Thank you for joining us on this exploration of how machines learn. We hope this guide has made the concepts of supervised, unsupervised, and reinforcement learning clear and approachable. Your curiosity and dedication to learning are what drive innovation in technology. Stay tuned for more straightforward tech education, and remember to keep asking questions and seeking knowledge. As you continue your learning journey, stay connected with the community and share your progress. Engaging with others helps reinforce your understanding and opens doors to collaboration and new ideas. Keep growing, stay inspired, and remember, every step you take brings you closer to mastering machine learning. Until next time, stay curious and keep learning.